So guys, we are starting with higher order derivatives. Okay. So now let us understand few things over here. If y is equal to f of x, okay, d by dx of y, that is the derivative of y, is nothing but f dash x. So this is first order derivative. This is first order derivative. Then if we derivate this once again, okay, so d by dx of dy by dx. Okay, if we are derivating this once again on both the sides. Okay, so this part is nothing but d square y by dx square. See, try to understand. We are not multiplying these terms. It's not multiplication of d by dx into dy by dx. It's derivative of d by dx, derivative of dy by dx with respect to x. So, derivative of dy by dx is nothing but d square y by dx square. It's a notation. And derivative of f dash x is f double dash x. So, this is the second order derivative. Okay, this is the second order derivative. Okay, so let me just put it down once again. Y is equal to f of x. This is the basic function dy by dx. First order derivative, that is f dash x. This is the first order derivative. D square y by dx square is equal to f double dash x. D cube y by dx cube. Derivative for the third time. It's f triple dash x. So these are all higher order derivatives. Derivating more than once. Okay. So these are just notations that you need to know. Okay. We'll start with the actual problems. Yeah. So now, first of all, exercise 8L. I'll be solving question number 3 onwards because question number 1 and 2 I just give it for self study. Okay, so question number 3 onwards will start exercise 8L. Now look at the problem statement. The problem statement says y is equal to 2 sin x plus 3 cos x. This is the problem statement. And they're asking us to prove something. What we are supposed to prove? Y plus d square y by dx square equal to 0. So this we are supposed to prove. So y is nothing but the function itself, and d square y by dx square is nothing but derivating the function twice. Okay. So first of all, what I'm going to do is I'm going to derivate it once, derivating this with respect to x on both the sides. So dy by dx. Derivative of y is nothing but dy by dx. Okay. 2 is a constant. Derivative of sin x is cos x. Plus 3 is a constant. Derivative of cos x is minus sin x. If you're writing minus sin x, put a bracket for that. Okay. So dy by dx is equal to 2 cos x minus 3 sin x. Okay. And just go to the previous page for you to note down. Fine. So this plus 3 into minus is minus 3. Fine. Now they're asked in the proof they have used d square y by dx square. So we'll derivate this once again. The derivative of dy by dx, once again it is d square y by dx square. This is the second order derivative. Okay, 2 will remain as it is. Cos x derivative is minus sin x, and 3 is a constant. Sin x derivative is cos x. Okay, so d square y by dx square is equal to minus 2 sin x plus 3 cos x. So we got the second order derivative. Fine. And we also have the first order derivative, that is dy by dx. We have both. Right. So this is the first order derivative and this is the second order derivative. Now we will try and prove whatever is given to us. We'll try and prove that. Okay, so for that reason we'll have to start with the LHS part. LHS is equal to y plus d square y by dx square. Now both the values we have both the values. Y value is given in the question, and d square y by dx square value we have just calculated. So the value of y is 2 sin x plus 3 cos x, and value of d square y by dx square. D square y by dx square is minus 2 sin x plus 3 cos x. Minus 2 sin x. Uh, just a second. It's minus. Sorry, this is minus over here. Right? Minus 3 cos x. So are all the terms getting cancelled over here? Yes. So this is equal to your RHS. This is equal to your RHS. Okay. Yes. I'll just go back to the previous slide. Right. Okay. Now one more thing about these notations. This is also called as y1, and it is also called as y dash. Okay. This is called as y2. This is y double dash. So this notation is also we try and remember. Instead of giving d square y by dx square. Oh, sorry. This is one second. This is y1. I'm sorry for that. This is y2. This is y2. This is y dash. This is y double dash. This is y triple dash. Okay. Yeah. So just try and remember this notations as well. Okay. So let us go to the next problem. Question number 3, sub question 2. Yeah. So y is equal to a into y equal to a plus bx square. What we are supposed to prove? See, we are supposed to prove x d square y by dx square is equal to dy by dx. So this we are supposed to prove, right? So we require both the derivatives, first order derivative, second order derivative. So we'll try to find out that. So first differentiate this with respect to x on both the sides, d by dx on both the sides. So this will become dy by dx. A derivative is 0, b into 2x. So dy by dx, first order derivative is 2bx. Okay. Now derivate this once again. Derivate this once again. Derivative of dy by dx is d square y by dx square. 2b is a constant. Derivative of x is 1. Okay. Derivative of x is 1. So d square y by dx square is equal to 2b. So we got both the derivatives. First order derivative and the second order derivative. Now take a look at the proof. Take a look at the proof. In the proof part, we will start with LHS. The value of the LHS is x d square y by dx square. LHS is equal to x d square y by dx square. So this is x into 2b. We got this value, right? Okay, so this is equal to 2bx. Okay, now see 2bx. Go to the previous slide and check what is 2bx. 2bx itself is dy by dx. 2bx itself is dy by dx. So this is dy by dx, and that is equal to your RHS. This is equal to your RHS. Okay, that was question number 3, sub question 2. Okay, So let us start with 3 sub question 3. Okay, just take a look at the problem. 3 sub question 3. Y is equal to sec x tan x plus sec x. Okay, and we need to prove d square y by dx square is equal to cos x upon 1 minus sin x the whole square. Okay, so we can solve this there are multiple ways to solve this. You can either start with direct derivative or you can convert this into sin and cos. So I'll just convert this into sin and cos because in the proof only sin and cos terms are there. Okay, so this is sin x upon cos x. So this can be written as 1 plus sin x upon cos x. 1 plus sin x upon cos x. Okay. Now in the proof, if you take a look, RHS of the proof is cos x upon 1 minus sin x the whole square. Okay. Now somehow I'll try to bring that 1 minus sin x over here down. Okay. So I will take the conjugate of the numerator to get that 1 minus sin x upon in the denominator. And yes, once again, I'm saying that you can derive from this point also. You can take u upon v and solve. But then I'm trying to get that 1 minus sin x down. So I will take conjugate of the numerator. Okay. So y is equal to, now look over here. This is a plus b into a minus b. So a plus b into a minus b is a square minus b square upon cos x 1 minus sin x. So this in turn is 1 minus sin square x cos x into 1 minus sin x. Cos x into 1 minus sin x. Okay. Now 1 minus sin square x, you can apply fundamental identity. Derivative of 1 minus sin square x, sorry, the value of 1 minus sin square x is cos square x. So in the next step, I'm going to write y is equal to cos square x upon cos x into 1 minus sin x. Now one cos term will get cancelled over here, right? So it is eventually cos x upon 1 minus sin x. Now I'm going to derive dy dx. Okay, so the derivative of y is dy by dx. And right hand side, I'm going to apply quotient rule u upon v. So this is equal to 1 minus sin x d by dx of cos x minus cos x d by dx of 1 minus sin x. I hope you all know what is u upon v rule. And this is 1 minus sin x the whole square. Okay. So dy by dx equal to 1 minus sin x into minus sin x. Derivative of cos is minus sin minus cos x. Derivative of 1 minus sin x. Derivative of 1 is 0. Derivative of sin x is cos x, but then there is a minus sign in between. So it will be minus cos x. Put a bracket, otherwise it will change the meaning completely. So brackets are very important. Okay. So now we'll have to multiply this. 1 into minus sin x plus, that is minus sin x. So this minus sin x will get multiplied within the first bracket. Okay. So dy by dx 1 into minus sin x is minus sin x plus sin square x. Now how this is plus sin square x, let us see. Minus sin x into minus sin x is plus sin square x. and this also, this term also is plus cos square x. Okay, so this is plus cos square x upon 1 minus sin x the whole square. So dy by dx, sin square x plus cos square x is 1. So this is 1 minus sin x upon 1 minus sin x the whole square, which in turn is 1 upon 1 minus sin x. We got the value of dy by dx. Any feedback? Have you understood this or is it difficult? Okay, then we'll derive this once again. So derivative of dy by dx is d square y by dx square. Now here, over here, we are going to use 1 upon x formula. Derivative of 1 upon x is minus 1 upon x square. So derivative of 1 upon 1 minus sin x is minus 1 upon 1 minus sin x the whole square. So if you compare, x is 1 minus sin x, okay? That's the chain rule. So into d by dx of 1 minus sin x, okay? So this is minus 1. Derivative of 1 minus sin x is minus cos x upon 1 minus sin x the whole square, right? So now this minus, this minus 1 into this minus is plus. And then we got our proof. D square y by dx square is equal to cos x upon 1 minus sin x the whole square. Is that clear? Have we got our proof? Are you referring to the problem statement? Okay. So if you are having any doubts, you can please ask. But then this is what is the final answer, right? So let us go to. Should I start with the next problem, or you require some time? Yeah. So question number three, sub question five. Yeah. Three sub question four. Sorry. Y is equal to 500 e raised to 7x plus 600 e raised to minus 7x. Now look at the proof. They're asking you to prove d square y by dx square is equal to 49y. Okay, so first I'm going to derive this with respect to x. So dy by dx, 500 will remain as it is. D by dx of e raised to 7x is e raised to 7x d by dx of 7x plus 600 e raised to minus 7x dy dx of minus 7x. Okay, so dy by dx is equal to 500 e raised to 7x into 7 plus 600 e raised to minus 7x into minus 7. So this in turn, I'll take 7 common. This step is very important. 500 e raised to 7x. I'm taking 7 common. So 600 e raised to minus 7x. But then at the same time, this plus into this minus will be minus in between. So this is the value of dy by dx. This is the value of dy by dx. Okay. Just take 7 common. So I'll just put this on the next page for you. dy by dx, 7 outside, 500 e raised to 7x minus 600 e raised to minus 7. Derivate this once again d by dx. So d square y by dx square 7. 500 e raised to 7x is 500 e raised to 7x into d by dx of 7x minus 600 e raised to 7x derivative is 600 e raised to 7x into d by dx of minus 7x. Okay. So d square y by dx square is equal to 7. 500 e raised to 7x into 7 minus 600 e raised to minus 7x into minus 7. Okay. I've applied the chain rule. Now again I'm going to take 7 common. Just take 7 common. And at the same time, in between this minus and this minus will be plus. So let me take that 7 common. Now when I take the 7 common, outside there is already a 7. Okay? Outside there is already a 7. So 7 into 7 will be 49. 500 e raised to 7x plus 600 e raised to minus 7. Okay, I've taken 7 common outside. That 7 and this 7 will be 49. And then this minus minus is plus. Okay, now look at the box bracket. Please take a look at the box bracket. What is the value of the box bracket? Can you figure it out from the question? The value of the box bracket is y. Okay, the value of the box bracket is y. Right? So 49y. That's it. So d square y by dx square is equal to minus 49y. So we got our required solution. This is what was asked earlier. Okay, let us begin with the next problem. We have copied this. We'll just go to the next problem. Okay. Yeah. So I'll take you to exercise 8L, question number 3, sub question 5. Question number 3, sub question 5. Okay. So e raised to y 1 plus x is equal to 1. Fine. So we are supposed to prove something over here. D square y by dx square is equal to dy by dx d whole square. That is what we are supposed to do. Fine. So first we'll derivate this d by dx. Left hand side we are going to apply product rule u into v. So v derivative of u plus u derivative of u equal to 0. Derivative of 1 is 0 on the right hand side. So 1 plus x derivative of e raised to y is e raised to y d by dx of anyone d by dx of y. Okay, plus e raised to y derivative of 1 plus x is 1, which is 0. Okay, now just observe this part, the thing which I'm highlighting right now. Just observe that this particular part. What can you comment about this particular part? Is it 0? Sorry, is it 1? The value of 1 plus x raised to y, is it 1? Yes. Okay, so this is 1 dy by dx plus e raised to y is equal to 0, right? So what is eventually the value of dy by dx? The value of dy by dx is minus e raised to y. So dy by dx is equal to minus e raised to y. Okay, let me go to the previous slide. See, now we also require d square y by dx square. So derivative this once again, d by dx on both the sides. So derivative of dy by dx is d square y by dx square. Minus will remain as it is. E raised to y derivative is e raised to y d by dx of y. D by dx of y. Okay. Now it depends on your observation. Once again, please tell me what is the value of minus e raised to y? What is the value of this? Come on, tell me. Yes, it's in this particular slide itself. So is equal to d square y by dx square is equal to this value is dy by dx. See, it's over here into dy by dx. So d square y by dx square is equal to dy by dx the whole square. That's it. The proof is over. Right? Dy by dx into dy by dx is dy by dx the whole square. This is multiplication. Okay. Yeah. Clear? Do you have any doubts to ask in this particular problem? Or you understood? Waiting for your feedback. Hello. Let's go to question number 4. Y is equal to tan x. Okay. D square y by dx square is equal to 2y dy by dx. That is what we need to prove. So first we'll derive this. Dy by dx is equal to derivative of tan x is x square x. So first order derivative. Now trigonometric function with a power. Take the power outside. Okay. Now derivative this. Derivative this once again. Derivative of dy by dx is d square y by dx square. Derivative of sec x the whole square is x raised to n, that is x raised to 2, n is 2 over here. Suppose x raised to n formula will be there. Derivative of x square is 2x, so derivative of sec x the whole square is 2 sec x. Who is x over here? If you compare, this and this, who is x? Who is x? If you compare, x is sec x. So d by dx of sec x will come as chain rule. So d square y by dx square 2 sec x, derivative of sec x is sec x into tan x. So this will be 2 sec square x tan x. Okay. So this is your d square y by dx square. So LHS is 2 sec square x tan x. Now let's proceed with RHS. See, LHS itself was d square y by dx square. So LHS is 2 sec square x sin x. Now let's proceed with RHS. Okay. So RHS is 2y dy by dx. 2y dy by dx. So y is tan x and dy by dx. dy by dx is sec square x. We have already done that. Dy by dx is sec square x. Now you tell me, is LHS equal to RHS? This is your final RHS. If you have copied, just tell me, are LHS and RHS terms same? Yes. Okay, so they are same. So that's how we'll prove this particular problem. It was a very simple thing. Yes, we can do this simultaneously, not a problem. At once you can prove it. Otherwise, you can also follow LHS RHS approach. We'll take a break of 2 minutes and then we'll start. Okay, so we'll start with the next problem. That is question number 5. Okay, and that is from the textbook. Exercise 8L. Y is equal to log x upon x. Y is equal to log x upon x. We need to prove d square y by dx square is equal to 2 log x minus 3 upon x cube. Just refer, d square y by dx square is equal to 2 log x minus 3 upon x cube. Sit with your textbook, everyone. Yeah. So dy by dx, derivative this once. We are going to apply quotient rule over here. X dy dx of log x minus log x dy dx of x upon x square upon x square. So dy by dx is equal to x into 1 upon x. Derivative of log x is 1 upon x minus log x into 1. Derivative of x is 1 upon x square. So this is 1 minus log x upon x square. 1 minus log x upon x square. How 1? Because we are supposed to cancel this x and this x. Okay. So we got dy by dx. But then the proof requires d square y by dx square. So we are going to derivative this once again. So derivative of dy by dx is d square y by dx square, and the derivative of 1 minus log x upon x square will be u upon v. So d square y by dx square u upon v will x dy dx of 1 minus log x minus 1 minus log x dy dx of x. I think it should be x square. Just a second. Yes, it is x square. Dy dx of x square upon v square. Okay. So d square y by dx square is equal to x square derivative of 1 minus log x. That is 0 minus 1 by x. Derivative of 1 is 0 minus 1 upon x. So the answer is minus 1 upon x. But put a bracket. Minus 1 upon log x. Derivative of x square is 2x. Okay. Upon x raised to 4. So d square y by dx square is equal to, now this square and this x will get cancelled and will be left with minus x. Okay, 2x into 1, that is minus 2x. Outside there is minus sign, and 2x into log x, it is plus 2x log x. Okay, because this minus and minus will be plus. The minus here and minus here will be plus. Okay, so upon x raised to 4. So this can be written as minus 3x. So d square y by dx square is equal to, I can write this as 2x log x minus 3x. D square y upon dx square will be d d square y upon dx square will be 2 log x, 2x log x, sorry, minus 3x upon x raised to 4. Now in the numerator take x common, so 2 log x minus 3 upon x raised to 4. Now one x will get cancelled over here, okay, and will be left with 3. The power is 3 in the denominator. X cube. Okay, and hence our proof is also done. I don't think so. We are supposed to prove anything else from here. So this itself is d square y by dx square, and hence proved. Just give me a feedback whether you have understood this problem or not. Yeah. Let us go to question number 14 and 15 first. Okay. So let's go to question number 14. Question number 14 says y is equal to a into e raised to mx plus b into e raised to minus mx. Okay. We need to prove d square y by dx square minus m square y is equal to 0. Now sometime back we had done such kind of a problem where m was 49, so 7. Okay, so m square is 49. Such kind of problem we have done. So it's the same kind of problem. Okay, so derivative first. Derivative of y is dy by dx. Derivative of a e raised to mx is a is a constant. A into mx e raised to mx into d by dx of mx plus b into e raised to minus mx into d by dx of minus mx. M is also a constant. So dy by dx a e raised to mx into m plus b e raised to minus mx into minus m. Take m common. Dy by dx is equal to m a e raised to mx minus b e raised to minus mx. How this became minus? The plus and minus over here will give you minus. So this is dy by dx. Okay. Now we are supposed to derive this further because the proof requires d square y by dx square. The proof requires d square y by dx square. Okay. So derive this once again. M will remain outside, it's a constant. Derivative of dy by dx is d square y by dx square. M will remain outside. Okay. Then again, derivative of a e raised to mx. A will remain as it is. E raised to mx is e raised to mx into d by dx of mx. B e raised to minus mx d by dx of minus mx. B e raised to minus mx d by dx of minus mx. Okay. Along with the chain rule. D square y by dx square is equal to m a e raised to mx into m, okay, minus b e raised to mx into minus m. So I'll take this m common from the box bracket. I'll take m common. When this m goes outside, it will get multiplied with the outer m, and it will be m square. So this will be a e raised to mx, and at the same time minus into minus will be plus over here. Okay, b e raised to minus mx. Now just tell me what is the value of the box bracket. What is the value of the box bracket? Come on, tell me. The value of the box bracket is y. Correct. Good. And that's how we complete our proof. D square y by dx square is equal to m square y. Okay, this much we have got. Shift the right hand side term to the left hand side. This entire term shifted towards the left hand side, and it will be minus m square y. Okay, that's how the problem will get over. Okay, yeah, that was question number 14. Let us start with question number 15. 1 5. Okay, so I'll be starting with question number 15 right now. Fine. Yes, let us focus on this particular problem. Y is equal to a cos log x plus b sin log x. Okay, and we need to prove something. X square d square y by dx square plus x dy by dx plus y equal to 0. So it's a big thing they're asking us to prove. The LHS part is quite big. It has three terms, and all the three terms are having d square y by dx square dy by dx this terms. Okay, so we eventually will have to derivate this twice. So d by dx, first time derivative, dy by dx, a cos log x is minus sin log x, d by dx of log x. Okay, so chain rule, apply chain rule over here. Cos derivative is sin. So a into minus sin log x d by dx of log x plus b into sin log x is cos log x dy dx of log x. Okay, so dy by dx is equal to minus a sin log x into 1 upon x plus b cos log x into 1 upon x. Now right hand side we have a common denominator. Okay, so we'll just write it, take it common, and make this thing as the entire denominator. So dy by dx is equal to minus a sin log x plus b cos log x the whole upon x. Okay, so dy by dx is equal to minus a sin log x plus b cos log x the whole upon x. Right? Okay. Now see, I'll shift this x on the other side. Otherwise, I'll have to apply u upon v rule on the right hand side. To avoid that u upon v rule, quotient rule, I'm shifting x on the right hand side. X dy by dx is equal to minus a sin log x plus b cos log x. Okay. Now derivate this once again. Derivative of x into dy by dx. This is u into v rule, and here we'll apply chain rule for both the terms. Okay. So v is dy by dx, derivative of u plus u derivative of v. Okay. Now right hand side minus a will remain as it is. Okay. Sin log x derivative is cos log x. So minus a cos log x dy dx of log x. Okay. Let's make it more compact. Is equal to minus a cos log x dy dx of log x. Okay. Plus b is a constant, cos log x is minus sin x, plus b cos is minus sin log x dy dx of log x. Okay, now this part dy by dx. Okay, dy dx of x is 1, so we need not write that one. Plus x. What is the value of this dy dx of dy by dx? Derivative of dy by dx. So it's d square y by dx square. Okay, equal to minus a cos log x into 1 upon x minus b sin log x. Okay, why minus? This plus into this minus is minus into 1 upon x. So dy by dx plus x d square y by dx square. We have a common denominator once again x, and take minus sign common from the numerator. A cos log x plus b sin log x. Okay, what I've done, I've taken x as the common denominator over here, and this minus sign I've taken common over here. Okay, now once again this x I will cross multiply on the left hand side. I just cross multiply this on the left hand side. So this will be x dy by dx x dy by dx plus x square d square y by dx square. X will get multiplied to both the terms. Multiplied to both the terms. Okay. Now this minus will remain as it is. What is the value of this box bracket? Can you tell me the value of this box bracket? This box bracket. Y. Correct. Perfect. That's from the question itself. So this is equal to minus y. Right. Now take that minus y on the left hand side and make it plus y equal to 0. And this is how you get your proof. Hence proof. This was what was required earlier. Fine. Okay. So this is the end of the session number 1 on higher order derivatives. Thank you.